The world thinks the space race ended in 1969. They're wrong. What started as a Cold War sprint has exploded into a global marathon. Now, the new race is on for the Moon and Mars. NASA, China, India, and the private giants. They're all locking in their goals. Who is leading? What are they building? And where does competition turn to cooperation? This is the new age of ambition. In this video, we'll trace how the modern space race formed. NASA's Artemis, China's Chang'e program, India's Chandrayaan successes, and the private push from SpaceX to Starship. It's a story of ambition and overlapping goals. We'll show you the clear timeline of who is leading, what data they share, and where competition might turn to cooperation next. From Cold War rivalry to shared orbits. The space race is often said to have ended in 1969, when humans first set foot on the Moon. But if we look closer, that finish line never truly existed. The drive to reach beyond Earth only changed speed and shape. What began as a sprint between rival powers became a steady relay among nations, agencies, and now private companies. The question isn't whether the space race ended, it's how it quietly kept going. In the early 1960s, the contest between the United States and the Soviet Union set a tone for global science unlike anything before it. The goal was simple on the surface: reach the Moon first. Yet the deeper purpose was to prove which political system could turn technology into destiny. When NASA was created in 1958, it was designed to act in public view. Its launches, failures, and research findings were broadcast as open knowledge, part of a democratic vision that science should be shared. The Soviet program took an opposite approach. Details of its rockets, test results, and even astronauts were kept secret until after success was guaranteed. That contrast, openness versus secrecy, reflected how each side defined progress. One sought visibility, the other reliability. When Apollo 11 landed, the tension that had driven both superpowers began to cool. The world watched one of history's great milestones, but soon after, budgets tightened and public focus shifted. Domestic issues and the Vietnam War pushed space exploration off political priority lists. Many assumed the space contest was over. Yet quietly, scientists and engineers continued building on the knowledge gained. Experiments aboard orbiting satellites deepened understanding of Earth's climate. Unmanned probes extended our reach to Mars and the outer planets, storing data that later missions would refine. The visible race may have slowed, but the technological race accelerated. After Apollo, direction changed from single targets to sustained presence. The United States launched Skylab, a short-lived but valuable orbital laboratory. The Soviet Union followed with Salyut stations and later Mir, the first long-duration outpost in space. Living and working continuously in orbit shifted the focus from victory to endurance. By the 1990s, former rivals were now docking spacecraft together. The International Space Station embodied that shift, completed through modules from Russia, the US, Europe, Japan, and Canada. It represented a shared commitment rather than a title chase. The collaboration flowed from treaties that defined space as a common domain. No nation could claim ownership of the Moon or planets, but all could explore them peacefully. As cooperation grew, other countries built their own paths into orbit. The European Space Agency formed in 1975, pooling national efforts to support ambitious missions like the Mars Express Orbiter and the Rosetta Comet probe. Japan launched communications and lunar research satellites. India developed cost-effective rockets capable of planetary missions. These programs expanded the definition of the space race. Success was no longer measured only in flags planted, but in capabilities built and data shared. Even without the spotlight, the pace of innovation stayed intense. Satellite networks now map Earth's surface daily. Spacecraft send images from beyond Neptune. Reusable rocket technology, pursued first through experimental models and later refined by private firms, reduced launch costs and opened commercial routes once reserved for superpowers. So, instead of ending, the space race evolved into a distributed effort of global capability building. The mindset of contest remained, but the players and goals multiplied. Instead of proving ideology, participants now demonstrate access, efficiency, and resilience. Every launch tests not only engineering, but diplomatic balance. The legacy of Cold War ambition has become a network of partnerships threaded through modern missions. And as those networks grow, a new chapter is already forming, one that stretches from shared orbits to permanent outposts on the Moon and beyond, where collaboration and competition meet again under different stakes: the new contest, Moon bases, Mars goals, and market access. Today's launch manifest reads like a scoreboard from the 1960s, but the competitors now come from every continent. Space agencies list new lunar landings, satellite constellations, and Mars probes every year. So who actually leads this renewed space race? The answer depends on how leadership is measured, by the number of launches, the reach of technology, or by who defines the rules for operating beyond Earth. The results shift constantly as national programs and private companies push forward for different reasons. NASA's Artemis Program sets one of the most visible milestones. Its main objective is to return astronauts to the Moon within this decade and to build a long-term base near the South Pole, where ice could supply water and fuel. The project relies on a global network of partners through the Artemis Accords, a framework that promotes transparency and peaceful use of space resources. More than 24 countries have signed on, each contributing hardware, funding, or research expertise. Their participation forms a shared infrastructure: European service modules for crewed spacecraft, Japanese cargo landers, and contributions from Canada's next-generation robotic arm. For NASA, Artemis links exploration with diplomacy, turning each mission into a test of international coordination. China advances on a parallel track. Its Chang'e Lunar program has moved steadily from orbiters to landers to sample return missions. The next step, the International Lunar Research Station, is planned as a long-term science base jointly built with Russia and open to other partners. Unlike the US-led alliance, this pathway develops under separate agreements, reflecting a different vision of governance in space. The contrast reveals how the Moon now represents more than scientific curiosity. It has become a stage for defining future systems of cooperation and control. Every major agency cites exploration and science as official motives, but other layers are visible. For the United States, leadership supports technological industry and ensures safe standards for commercial use. For China, success demonstrates national capability and global presence. For new entrants, credibility grows through demonstration missions that prove reliability on smaller budgets. India's Chandrayaan-3 mission, which achieved a soft landing near the Moon's south polar region, showcased precise navigation and efficient mission planning. Its goal was scientific, but its outcome also positioned India among the few nations to complete a controlled lunar descent, a statement of both skill and independence. Private companies now weave through nearly all programs. SpaceX provides launch services for national agencies and develops Starship as a cargo and crew transport for Artemis. Blue Origin is designing its own lunar lander and heavy lift rocket. Axiom Space plans to operate commercial modules attached to the International Space Station before building an independent orbital platform. Their reusable systems repeat what early government programs attempted, but with market incentives replacing central budgets. Each successful reflight proves the cost and efficiency hypothesis that long-term operations may depend more on economy than geopolitics. This market-driven shift brings new questions. Among them, who owns the data collected by mixed partnerships, and how are discoveries shared across national boundaries? International law under the Outer Space Treaty forbids national appropriation, yet ambiguity remains about private extraction of lunar resources such as water ice or metal oxides. The consensus view is that legal frameworks will evolve through practice, guided by transparency agreements and export regulations, but the process remains uncertain. Each mission effectively sets a precedent for how humanity manages the commons of space. Taken together, the new space race is neither a pure competition nor a single enterprise. It operates as a network of public and private projects linked by supply chains, data exchange, and shared goals of a sustainable off-Earth presence. Rockets still symbolize prestige, but cooperation increasingly defines progress. If the lessons of the first space age continue to hold, collaboration may yet prove to be the fastest route outward. Conclusion. The space race never concluded. It unfolded into a longer effort shared by nations, agencies, and companies. What began as a Cold War contest became a marathon of sustained exploration. Progress now depends as much on shared science and governance as on hardware or budget scale. Each mission demonstrates how cooperation shapes results once driven by rivalry. The consensus view is that space leadership now includes accountability for stability and sustainability. Upcoming lunar, Martian, and commercial projects will test that idea further. Staying informed helps us measure not only who advances first, but how humanity chooses to extend itself beyond Earth.